Next section of conics is on hyperbolas. Notice the homework is all from section 10.4. Our objectives very similar to the previous sections. We're going to graph them and make sure we include all this important information. And then we're also going to write equations given different facts about the hyperbola. So this equation of a hyperbola looks very similar to the equation of an ellipse. The only difference is this negative sign. So not only does the fact that one of the terms is negative make it a hyperbola, but the term that's negative tells us which way it opens. So when the y term is negative, and there's always only one negative, the hyperbola is going to have a horizontal transverse axis, which means that the curves open sideways. So that's the example that I have over here. And we're going to talk about what the transverse axis is in a minute. So a lot of the things are the same as an ellipse. So the center is HK, just like it always has been. So this is this is HK. And then A, the square root of the denominator under the x, and I'm going to keep that consistent. A is always going to be under the x term and B under the y term. The book swaps them. So just be aware that the book's not using that same convention that I am. So we're going to find the vertices of the curves. It's tempting to say they're two parabolas, but they're not. Hyperbolas have asymptotes and parabolas do not, so they're not the same shape. So the vertices move a distance of A away from the center. So we're opening sideways, so we have to move horizontally. So the distance between the center and the vertex is A in both directions. Crazy. So the coordinates of the vertices are, we're going to move H, so H plus A, and keep the Y height the same. And likewise over here, it's going to be the horizontal component of the center moved to the left A, and the height is going to stay the same. So that's what we have here. And then we're going to draw in our transverse axis. It goes from one vertex through the center to the other vertex, and so that is the transverse axis, and it has length 2a, because from the center to one side is A, and from the center to the other side is also A. So now we're going to work on the equations of these asymptotes. So notice the asymptotes go through the center, both of them. Now we're going to use the value of b before we move on. So b is the square root of the denominator of the y term, and that's going to tell us something about the slope of the axis. So one easy way to graph it is to start at the center and go up a distance of b, just like we went left, right, a distance of A to plot the vertices. We're going to go up a distance of B. So I'm going to go up B, so that distance is B, and then I'm going to go down a distance of B from the center. Make sure I land in the right place. So that's a distance of B. And then I'm going to draw a box that goes up. Like the top of the box is up B from the center, the bottom of the box is down B from the center, and then the left and right of the box vertically go through each vertex. So I've got a box. Now the box is not part of the graph of a hyperbola, but it helps us get the slope of the asymptotes. So notice the asymptotes go through the corners of that rectangle. So can we figure out what the slope of this asymptote is? Well, it's centered at that point, okay, but what's the slope? The slope, if I start at the center, I go up B and right A to get to another point on the line. Therefore, the slope is B over A. So I'm going to easily be able to write an equation of this line now in point slope form. So it would be y minus the y coordinate of the center equals the slope times x minus the x coordinate of the center. Sorry, this was a k. So there you have it. So this other asymptote is also going to start at the center and go the slope to get the slope up b, but then left a. So this slope is negative b over a. So the equation of this line is y minus k equals negative b over a times x minus h. So we drew the asymptotes, and then we also wrote the equations of them, and here's how you find them. And the last thing before we just graph the little curves and move on is to find the foci. So they're related to C. So notice how C, A, and B are related is slightly different than how they were related in an ellipse, so make sure you don't get it mixed up. This is a sum, and A squared and B squared are the denominators. So use that, calculate C, and then to find each focus, you move the center, in this case left, right. So I take the h coordinate, move it left a distance of c, so this distance is c, and this distance is c to get to the focus. So now there are the foci, and once you have that, these is obviously already graphed, but you want to make a curve that goes through the vertex and heads toward the asymptote on each side. And there you have it. So now let's turn the paper and look at a hyperbola with a vertical transverse axis. So we'll do this one a little faster. Notice the only difference between the one we just did and this one with a vertical transverse axis is that the x term is negative, and everything else is the same in the equation. Okay, so like in all of these conic sections, the center is hk, so there's the center. Oh, sorry. The fact that the x term is negative means that it opens vertically. Okay. So now the vertices are going to move up and down b, so that's the square root of the denominator under the y term. So these distances are going to be b. All right. And then we're going to talk about the transverse axis, which is vertical, so it always goes from one vertex to the other and through the center, and the transverse axis has length 2b this time. Alrighty, now we're going to draw our box. So part of the box touches the vertex, and then in the other direction it's going to move a distance of a, just like the vertices did in the horizontal direction on the other example. So if I go to the right a distance of a, and to the left a distance of a, and draw my box, then the asymptotes go right through the center of the box. And because the vertical height from the center of the box is b, and the horizontal distance from the box to the asymptote is a, the slope of the positive slope line is still going to be b over a. So the equation of both asymptotes is exactly the same as it was in the other sideways opening hyperbola. You find the foci exactly the same way. C squared is the sum of the two. And so the foci are going to be from the center a distance of c down, so that distance is c, and from the center up to the focus is a distance of plus c. Alright, so we're done with that. Now we're going to do this example. So we're going to graph this hyperbola and label all the important things. So the first thing is, this is not in standard form, so we're going to have to complete the square. So let's see if I can do that kind of fast. So I'm going to factor the 9 out, and I get of the x terms. Leave space to add a constant, and I'm going to factor the 16 out and leave space to put in a constant. And it's going to be, sorry, I'm going a little bit like around the twisty here, but Anyway, on the other side of the equation is a 16. So to complete the square, I do negative 8 over 2 squared, so I'm going to add 16, which means I added 9 plus 16 to the left, so I have to add 9 plus 16 to the right, and then complete the square here, so negative 2 divided by 2 is negative 1 squared is 1, so add 1, but I really added negative 16 times 1, so I subtracted 16, so I'm going to subtract 16 here. So now this is 9 times x minus 4 squared minus 16 times y minus 1 squared. 16 minus 16 is 0, so it equals 144. We're getting closer. I want a 1 on the left, so I'm going to divide both sides by 144. 9 and 144 reduces, so we get x minus 4 squared over 16 minus y minus 1 squared. Again, the 16 and the 144 simplify over 9 equals 144 over 144, which is 1. Okay, great. This is a hyperbola. So the y term is negative, so I know it's going to have a horizontal transverse axis, so it's going to look like that. That's the negative on the y term. So let's write down all the things that we know. So the center, HK, is going to be 4, 1. And then let's identify A and B. So A is the square root of 16, so 4, and B is the square root of 9, so 3. Might as well find C while I'm at it. So C squared equals 4 squared plus 3 squared. So C squared is 25, so C is 5. Okay, so now we know all of those things. So I'm going to graph the center. So the center is 4, 1, so that's the center. And then to find the vertices, I'm going to go horizontally because I know it opens horizontally. I'll do it over here. So to find the vertices, we're going to start at the center, and we're going to move left a distance of A and keep the y the same. So that's 0, 1. And start at the center and move right a distance of A. So that's 8, 1. So that's a vertex, and that's a vertex. And I need to draw my box. So B is 3. So I'm going to go, I'll just count it. 1, 2, 3, so up 3, so that was B. And down 3, 1, 2, 3, so that's B, 3, okay. And draw my box. Now I'm ready to draw the asymptotes. They go through the corners of the box, which forces them to go through the center, and likewise over here. So those are my asymptotes. Might as well write the equations while I'm at it. Asymptotes. So it's going to be y minus 4 equals, so this goes up 3, right 4. I just forgot what they were. 3 over 4 times x minus 1. And the other one has a negative sign, so I get one where there's positive and one where there's negative. So this would be the positive and this would be the negative slope. The only other thing I need is the foci. So to find the foci, I go in the same direction horizontally. So I start at the center 4 and I move to the left 5 and keep the y the same. So that's negative 1, 1. And the other one I move to the right 5. So that's 9, 1. So I have one here and another one here. And now I'm ready to graph it. So I touch the vertex and head toward the asymptote, touch the vertex, head toward the asymptote. Same thing over here. Remember, it touches the vertex, it doesn't touch the focus. And that's that. One more. So Now we need to write the equation of a hyperbola, and we're given both foci and a point. So I'm actually going to start by building a rough sketch with the information that I know. It helps me synthesize it. So the center, no, I start with the focus. So we have 2, -2, and 2, 4. Okay, so that's the other focus. So the center is the midpoint. So I would do 2 plus 2 over 2, -2 plus 4 over 2. So the center is going to be 4 over 2 is 2, 2 over 2 is 1, so 2, 1. So that's the center. And now I need to figure out any of the other values that I need. So I think I find this distance, that would be helpful. So the distance, the only change between these two is the height. So from a height of 1 up to a height of 4, that is a 3. And the distance between the center and the focus is C. So C equals 3. All right. And I also have a point. So let's plot that here. So we have the point 2, 3. So that would be here. So that's the point 2, 3. So this is a point actually on the hyperbola. And since it's on a vertical line that goes through the foci, so that's the transverse axis, that has to be a vertex. If it was somewhere else, it wouldn't have to be a vertex, but because it's on the transverse axis, it has to be a focus. So that actually gives us tons of information, because the distance between a vertex and the center is, in this case, because it's vertical, it's B. So that's B, and we can subtract 3 minus 1 and get that B is 2. So B is 2, super helpful. Now we have enough information to calculate A. So C squared equals A squared plus B squared. So C squared is 9, A squared I don't know, and B squared is 4. So that tells me that A squared is 5, so A is the square root of 5, which is approximately 2.2, because I'm going to have to make a rough sketch later. So I need, actually I'm pretty much ready to write my equation, so I'll do that because that was the first part of the goal. So I know that I'm going to have x minus, where's my center, 2 over A squared, so A squared is 5, and then it opens vertically, so the x term is negative and the y term is positive, and then this is going to be y minus the y coordinate of the center squared over b squared, so that's going to be 4, and it always equals 1. So I wrote the equation. So now I'm just going to finish out the graph. So we have to move to the right a distance of b, no, A, sorry, because A is horizontal, so that would be about 2.2, so 1, 2.2, so about here, and to the left 1, 2.2, so about here. I'm drawing my rectangle. My other vertex, so this went up 2 from the center, so it's going to go down 2 from the center, so that's my other vertex. So I make my box like this, and I'm going to draw my asymptotes like that, and now I'm ready to graph my parabola. Hyperbola. It touches the vertex, heads toward the asymptote, touches the vertex, heads toward the asymptote, and then, didn't really say in the question, but just for the fun of it, let's write the equations of the asymptotes. So it would be y minus 1 is equal to the slope, which is b over a times x minus 2, and we get one of each. And that's all.